Hello everyone, this is Kumaraswamy and our project is AgentMonitor, Predictive and Secure Multi-Agent Monitoring System or Framework. In simple words, this is a AI tool to make AI systems agents more reliable and safe. AI agents here are like smart workers which works on different tasks. So our framework helps predict how well the system will do before it finishes and fixes any unsafe or poor quality outputs before they reach the end user. In the next few minutes, I will be walk through the business problem that it solves and also our solution and how it uses, what are the use cases of it, and what are the technologies behind it, and what are the benefits and who are the beneficiaries from this framework. So now let us discuss about the business problem that it solves. In modern AI, a multi-agent system means which contains several agents, so which work on a specific task. So but the problem here is, so these systems are very sensitive to setup. You have to keep trying different types of configurations to get a output or best result. So this is a trial and error approach which takes a lot of computational time and effort or resources. So sometimes after completing of all the things or after finalizing all the configurations, you may get a result which is inappropriate or maybe wrong. So for example, in a medical AI, so the with a wrong output can lead to several consequences. So the main business problem is how to get reliable, safe results without wasting time and resources. So here we came up with a solution. So our solution is called AgentMonitor. Think of it as a safety and performance inspector that works in real time. So it's a plug and play, meaning if it can be added to any AI system, so any multi-agent system easily without redesigning the old configuration or old things. So I will give you a specific idea how it works briefly. So it watches the conversation between every AI agent, so collects useful signals like which are called as indicators, so uses a predictive model to predict the performance before it actually done, so in the training phase only. So if the forecast shows problems, so then we will go a specific approach called as post edit, so which edits the output from the agent which thinks it has a harmful content, so it will be edited to the safer content, so and it will be given to the next agent. So now let us discuss about the users and interaction. So we will design the agent monitor for three main group of people. Multi-agent system developers, they add our tool into their system using just one API call. And system operators, so they watch dashboards showing performance scores of the multi-agent systems. So end users, they don't even know our tool is there, so they just get better, safer results. However, here's how it works step by step. AI system sends a task to a agent, and agent monitor collects their messages. Our system extracts indicators and run our predictive model. If needed, a language model or an LLM edits the output to remove harmful content and low quality content. So the final safe result will be sent to the user. Next, next we will discuss about the data and technology and the target users. So points to say, uh, our system is powered by both real world and benchmark datasets, Human Evolve, MMLU, GSM 8K. So what are these? So Human Evolve is a test codes generation skills. So it is like we can test the coding, what the code and how the code works, is it good or not. So MMLU tests the reasoning ability, and the GSM 8K tests math problem solving skills. So we also collect all the indicators logs from multi-agent systems to make the predictive model more accurate. Before using any data, we verify it's correct, validate it against the right answers, normalize it so our model can read it properly. So what are the technology stack that we use? Python for development. So XGBoost, a predictive model, regression model, which is used for predicting of the performance of the multi-agent system. So we can go with the Llama 3 or GPT-4 for language tasks. So AutoGen, LangChain or MetaGPT for multi-agent workflows. So now let us discuss about the target users. So our main users are AI or ML engineers who build applications on AI or multi-agent systems. So multi-agent framework developers who create tools for multi-agents to work together. So enterprise AI integrators, companies using AI for big business operations will be using this agent monitor, and end users indirectly benefits because they receive safer, higher quality outputs without having to do anything. So now discuss about the base paper that we have got idea from. So our work is based on the paper called Agent Monitor. Our work is inspired by this research paper, and the base idea is to create non-invasive monitoring layer. This means we don't change the original system, we just observe and improve it. And the process works like this. Users gives a task, and the agent system grabs collect clues from the process. Prediction model checks success chances. So if needed, an AI post editor makes the result, improves the result. So in test, this method achieved a high accuracy correlation of 0.89 and reduced harmful outputs by 6.2%. And we will go with the conclusion. So we will discuss about the architecture diagram first. So here we will have a multi-agent system. So when the user gives a prompt, or the user gives an input, it will be sent to the agent 1 and first agent, and that will be sent, the output from the agent 1 will be sent to the LLM. So it will be generating some personal score and collective score, and by this way, and the output from the LLM after enhancement will be given to the agent 2, and the output from the agent 2 will be collected, and same process will go on. So after collecting all the personal scores and collective scores, and we will feed that all information to the XGBoost model, which works as a predictive model for our project. And the XGBoost model will predict the performance, and if the performance is very much low, then it will be sent to, the process will be started again, and after it reaches a specific threshold value, so if satisfies, so the final output will be given. So next, let us go with the conclusion. So to sum up, the agent monitor makes AI systems more reliable by predicting outcomes early. It improves by removing or refining harmful content. It saves times and resources by reducing unnecessary trial and error. The final product will be ready to use and cloud service, and that works with any multi-agent system setup. So thank you.